Hey, micro friends, welcome to another episode of Let's Talk Micro. As always, I'm so happy that you're here with me. And if this is the first time listening to Let's Talk Micro, well, thank you for choosing it as one of your podcasts. Okay, so last week we interrupted the series of gram negative cocci because ASM Microbe is approaching this year in Washington, D.C., and the way that the meeting is changing from previous years. So I wanted to do an episode of what are the changes for this year's meeting. And there's also a workshop for medical lab scientists, which is independent of their registration. So if you live in the area, in the Washington, D.C. area, I encourage you to take advantage of this workshop. It has topics for people that are trying to, advance in their careers. It has some microbiology topics. So take advantage of this resource. But I invite you to check out that episode where you know what to expect at the meeting, how is it different from previous ones. It's a great episode, and in it, I was joined by Dr. Bobby Pritt and Dr. Robert Tibbetts. Okay, so let's go ahead and jump into today's episode. And this is the conclusion of a series that we did about gram negative cocci, which, as we have mentioned many times, it can feel a little daunting. Sometimes we might feel a little nervous about reporting gram negative cocci because we're afraid of of the implications. So this series was meant to make us a little bit stronger when it comes to gram negative cocci. So we started all the way from the beginning talking about gram stains, we talked about media, biochemicals, how to identify them. And then we moved on to talk about the organisms themselves, like pathogenesis, spectrum of disease, any virulence mechanisms. And we covered what are three main players. Two of them are very, very important, very significant, and the third one is important as well, but sometimes not as significant as the other two. I mean, you still see it and implicated in some infections. So the main players are Neisseria gonorrhea and Neisseria meningitis, right? Very important. And then we talk about Moraxella catarrhalis. And we have been talking about how these organisms they have the same gram stain, but different stories, right? When it comes to virulence, diseases, and things like that. So one way to look at it is if you think of it like a band, like a musical group, these will be like the lead singers, the playing the main instruments, like lead guitarist, lead bass player, drums. So they are the front characters, very essential to the group. But in a band, you have sometimes other things, right? You have backup singers, you have backup, instruments and things like that. You have background singers, and they are still important to the group, right? The whole thing together is what makes the group what it is. So they're also important, but they are more in the background and not in the front, such as the lead members. So when it comes to gram negative cocci, today we're talking about the background singers of this group. And we have mentioned them already, but these are the organisms you see all the time on respiratory plates and like sputum cultures. And we collectively call them as non-pathogenic Neisseria. And we have mentioned them throughout the series. So we'll be talking about that. And also, as you know, in microbiology, we have things that very similar that don't follow the rules. So we have some rule breakers as well, which, there are some Neisseria and Moraxella species that don't follow the classic gram-negative diplococci rule. And this means that, they show up as rods or coccobacilli. So their gram stain is a gram-negative rod or a gram-negative coccobacilli. Don't you love this, right? How complicated things are sometimes in microbiology. We have many similar names. We have this whole deal with nomenclature and taxonomy. And then we have some species that, for example, in this case, some Neisserias that are gram-negative cocci and some that are gram-negative rods, and the same with Moraxella. So that is what today's episode is about. So we'll talk about what they are, where they live, where they can cause disease, and of course, how they look on media, biochemicals, and things like that. So once again, same story, same gram stain, for some of them in this case, and different stories. So let's go ahead and jump into this. So let's start with the non pathogenic Neisseria. And those of you that work on the bench and with respiratory cultures, I'm sure you're very familiar with them. And so these are a variety of Neisseria species that can be isolated from humans, besides Neisseria gonorrhea and Neisseria meningitis. And these include Neisseria lactamica, Neisseria souffleva, Zika, mucosa, flavescens, cinerea, Neisseria elongata, polysaccharia, and others. And elongata it's part of this group of this non-pathogenic Neisseria, but keep in mind that Neisseria elongata, the gram stain is not gram-negative cocci, but it is still part of this group, so it's mentioned with them. And as we have alluded throughout this episode, most of these organisms, they're normal inhabitants of the upper respiratory tract, and they have a high affinity for mucosal membranes and are just part of the usual throat and oral microbiota. And of course, you know this when you're looking at your respiratory plates, you look at that chocolate plate and that blood plate, you see these yellow or gray colonies. So we'll continue talking about them. So when it comes to this Neisseria species, there are also some that are recovered from animals, such as Neisseria animaloris and Weaveri, and these are found like in cats and dogs. And something very interesting that I found when I was doing research for this, and this is found in the Manual of Clinical Microbiology from the American Society for Microbiology. When it comes to these organisms, there's something called site tropism, which means that they have an affinity for like a specific cell type, organ, for example. And when it comes to this Neisseria, for example, Neisseria flavescens and subflava, they tend to colonize the dorsum of the tongue. And Zika, mucosa, and elongata are more associated with gingival plaque. So once again, when you're looking at respiratory cultures, you see this mix of gray, yellow colonies that are oxidase positive, and these are these commensal organisms known as NPM or non-pathogenic Neisseria. And throughout the episodes, we have been saying this. We have emphasized that seeing gram-negative cocci can sometimes make us uncomfortable because we are afraid of reporting the wrong organism. And as you know, Neisseria meningitidis, Neisseria gonorrhea, they are very significant. So when we see a gram-negative cocci on a source such as blood or cerebrospinal fluid, sometimes we feel a little afraid because we think that maybe we did something like we over decolorized our GPC and we're afraid of reporting it wrong, putting out there that the gram-negative cocci is in that sample. However, if we see it on a respiratory source, that's where you should feel comfortable because, as we have mentioned, they are part of they're commensal organisms in that part of the body. Okay, so as we mentioned, we collectively call them non-pathogenic Neisseria, and even though that's in the name, of course, given some conditions, they do have the potential of being pathogenic. And that is something that is not unique to non-pathogenic Neisseria that happens with other organisms. So definitely don't dismiss them outright, but however, most of the time they are commensal and they are considered flora. I mean, if you isolate one from like a blood culture, you still report it and you give that information to the healthcare provider. So even though they are part of the respiratory flora, sometimes, in an opportunistic fashion, they can cause disease. For example, there are reports of species like Neisseria subflava, mucosa, Zika, and elongata causing endocarditis, bacteremia, meningitis, and other invasive infections. And these are usually in patients with underlying conditions such as heart disease, immunosuppression, or intravascular devices. But I really want to emphasize, as I'm talking about this, that these organisms, once again, they're mostly commensal and they don't cause disease, but they do have that potential, and there are cases where they have caused it. So just keep that in mind. When it comes to animal associated Neisserias that we mentioned before, like Neisseria animaloris, which you can see it in dogs and cats, um, it can cause wound infections and bite associated infections in humans. But having said that, in the lab, you'll typically, when it comes to bites, like cat, dog bites to humans, you see Pasteurella a lot more, but you can see Neisseria animaloris in cases like this. Typically, with some of these organisms that you see in the respiratory tract, this Neisseria, so we don't fully identify them. Like, I mean, if we identify them, we don't report that ID unless there's a specific reason. So that's why we normally just release them as non-pathogenic Neisseria. And this is something very common that we do with other organisms. Like typically with coagulase negative staph in some sources, we just release that generic ID, CNS. So that's the case with these Neisserias. We just release it as non-pathogenic Neisseria. And those of you that work in the bench, You know that sometimes you look at these colonies and maybe some of them we have mentioned colors like gray and yellow and sometimes even a little tan, and maybe we put it on the moldy to rule out a Haemophilus. And then that ID comes back as one of these Neisserias. Okay, something interesting is that, for example, if you remember from the Neisseria gonorrhea and meningitis episode, one thing that we saw was that person to person transmission, right? As you know, with Neisseria gonorrhea, it causes an STD, and Neisseria meningitis, you see that it is transmitted from person to person in closed settings, right? Like dormitories and shelters. But when it comes to the non-pathogenic Neisseria, they cause disease mostly because the strain gets access to a normally sterile site. And some examples are bacteremia, endocarditis, and meningitis. But it is very interesting, right? Where you see the main players with that person to person transmission. And here, these organisms, they're commensal, they're part of that, in this case, of the respiratory flora. And then they gain access to a sterile site and cause disease. And for this particular group, not much is known about virulence factors. Okay, so right, we are bench tech, so we like our biochemicals, we like to know our media. So when it comes to NPN, they grow well on blood and chocolate. They are oxidase positive. Some of them are asaccharolytic, and you can identify them on commercial systems, but keep in mind that some of these are going to low discriminate. And to make sure that we are all on the same page, this is something that I have discussed before, but normally some organisms they are so closely related that when you put them on the moldy, let's say, you get like a low discrimination, meaning that it cannot decide between two different organisms. And you see that with Acarobacter, between Psilocystids and the nitrificans. You see that with Streptococcus dysgalactiae between two subspecies. So when it comes to some of these NPNs, you might get like a low discrimination or you get an ID like Neisseria flava slash subflava. So that's what I'm trying to say. And to kind of close the loop on gram negative cocci, I'm going to briefly touch on anaerobic gram negative cocci. And there are some species out there, but the one that I really want to talk about is Vilonella because it's the one that you more probably, in all likelihood, you will see in the lab. And unfortunately, sometimes it tends to be rare, and people think that maybe they over decolorize their cocci and then they're reported as GPCs. So, this is a good one to have in the back of your mind. So, these anaerobic gram negative cocci, they are part of the human microbiota and can be found in the oral cavity, genitourinary tract, respiratory tract, and intestine. And our friend Vilonella, it's part of the normal mouth and urogenital microbiota, and it's found in high concentrations in saliva and on the surface of the tongue. Vilonella can also be recovered from the upper respiratory tract and intestine, and when it shows up in infection, it is usually part of a mixed culture. So, just like the NPNs, these anaerobic gram negative cocci, they are typically commensal organisms, part of the normal microbiota of different areas, but given the right circumstances, they can cause disease. So please remember that. And this is something that I'm going to touch on very lightly. But if you go out there and you do the research, there are different reports out there when it comes to non pathogenic Neisseria. And there are some studies where it is mentioned that some, antimicrobial resistance components, these NPNs can carry them and then transfer them to Neisseria gonorrhea and meningitis through horizontal gene transfer. But this is something that I invite you on your own time to do some more research if you want to learn more about this. And then there are also some reports out there, some studies where, for example, like Neisseria lactamica may provide protection against meningococcal colonization. So if you are curious about this, I invite you to do some research and hey, maybe give some feedback via social media. Okay, so let's go ahead and talk about our rule breakers, right? We have been talking a lot about gram negative cocci, and we mentioned that there are some Neisseria species and some Moraxella species that are not gram negative cocci. So Neisseria elongata, Weaveri, Bacilliformis, they are short roots or diplobacilli and can sometimes appear in chains. So, Neisseria elongata is associated mainly with the oropharynx, but has also been reported as a cause of endocarditis. Neisseria basidiformis and Neisseria oralis have been isolated from the oral cavity. And Neisseria weaveri is linked to dog bite wounds, and in rare cases, septicemia. So remember this when you are on the bench, because sometimes we associate Neisseria and Moraxella with gram-negative cocci so much because of those main players. So sometimes we can be surprised when we get an ID back on a gram-negative brood, and it comes back as a different Neisseria species or a different Moraxella species. So they do exist. So let's talk a little bit about Moraxella species. So some of these species are coccoid or coccobacillary organisms, and they are described as plumb rods that occur in pairs or short chains. Some examples are Moraxella non-liquefacens and Moraxella osloensis, which are part of the normal upper respiratory tract microbiota, but have been associated with conjunctivitis, keratitis, bacteremia, and endocarditis. And these Moraxella species are asaccharilytic and oxidase positive. As far as media, overall they grow in blood and chocolate, and you have some gray to yellow colonies. And something very interesting is that some of these Moraxella species they actually can grow on McConkey agar, and they appear as non-lactose fermenter colonies. So keep that in mind. And when it comes to identifying them, nowadays a lot of labs have MALDI-TOF, so it makes things a little bit easier. But if you use other systems like the Vitek, for example, and you're using like the GN card or the NH card, it has a more limited database. So you have to remember that. So, and you might not be able to identify them. And something that I really like emphasizing is that, for example, if you get one of these non-claim organisms on the MALDI and you're trying to confirm that ID using a system like the Vitek, make sure that the organism is actually on the database of the Vitek, for example, or the identification system that you are using. Because if it's not, then you can get the wrong ID. As always, if you want to learn more about MALDI, I talk a little bit about the non-claimed in this series about the whole non-claim thing. But if you want to learn more about how Maldi works, I have done some episodes, so definitely go ahead and check the catalog. So to bring it all together, we have these group of gram-negative cocci that they are typically commensal organisms. You find them in your respiratory flora, but given the right circumstances, they can be opportunistic and cause disease. But overall, they tend to be non-pathogenic. And then we have these rule breakers because they carry the name Neisseria, they carry the name Moraxella, but they are not gram-negative cocci. But the same case, they are typically commensal, but they can cause disease. So it is good to know about them. It's good for us to get familiar with them. And in the scale of things, remember that when it comes to pathogens in this group, definitely you're gonna see Neisseria gonorrhea and meningitis and Moraxella catarrhalis. And when you see these other ones that we are talking about in this episode, mostly they're just going to be flora. Well, friends, we did it. We actually did a whole series about gram negative cocci, and I hope that this helps and it makes us a little bit stronger on the bench and a little more confident. And if this is your first episode, I invite you to go back to the other ones because we really broke it down all the way from gram stain biochemicals media and going over the different organisms. So it is a very comprehensive series. So if you haven't checked it out, please go ahead and do so. And as always, you can find Let's Talk Micro on any podcast platform. So if you go to Apple, Spotify, Amazon Music, Good Pods, we are right there. So please subscribe to the podcast, download episodes, and if the app allows you to do so, please leave a review. Thank you so much for the support. And hey, if you want to find us on socials, we are on Instagram, TikTok, YouTube, and Blue Sky Social as Let's Talk Micro, X as Let's Talk Micro 1, LinkedIn as Luis Plaza. And then there's the website, letstalkmicro.com, where you can find information about, study resources, licensing, episode updates, and more. And there's also the email address, letstalkmicro@outlook.com. So you have all these ways where you can provide feedback, any topic suggestions, via email, social media, website. So please feel free to use them. And If you want to support us in any way, you can do so via Venmo or via Buy Me a Coffee KOFI, and both links are available on the show notes. And friends, as microbiologists and infectious disease physicians, pharmacists, as members of this community, one thing that we know for sure is that learning about antibiotics is difficult. So if you're looking to learn more about antibiotics, please check out www.learnantibiotics.com and the Learn Antibiotics book available on Amazon. These resources include cheat sheets, practice test games, and more, and they are being used by thousands of people worldwide and may be helpful for you or your colleagues. And these are some great resources from Dr. Timothy Gauthier, a very passionate pharmacist. And as you know, the Let's Talk Micro podcast is supported by the American Society for Microbiology. To learn more about microbes, visit asm.org. And that, micro friends, it's the end of this episode. We did it. We wrapped up a series about gram-negative cocci. I hope you enjoy it. As always, I enjoy sharing this information with you. You know, I appreciate your support. Thank you for downloading episodes. I'm really grateful. And hey, if you're attending Microbe this year in Washington, D.C., you see me, hey, please, let me know. Say hi. I'm looking forward to meeting you and connecting with you. And stay tuned. There's something really great that's going to happen during ASM Microbe with the podcast. So stay tuned for more details. As always, please continue bringing that passion to what you do. It's so important. You do such great work. So, as always, stay motivated, stay safe, and of course, continue talking micro. Until the next time. Bye.